Thank you very much, Diana, for such a nice introduction, and welcome everyone. And I hope we'll spend this hour that will be both kind of, contentful, interesting, but also enjoyable, and yeah, a little bit of entertainment. So yeah, and last but not least, I am really kind of honored and grateful to speak in front of you, and I hope that after the war madness finally stops and finishes, we'll be able to meet live somewhere, hopefully. So, yeah, under the hood of LLMs and agents, why speaking about that at all? So, there has been a lot of things that have been already, said about LLMs. There are many groups saying that LLMs can, build a whole project and run it, or that no, they're totally useless, or that LLMs can think, or another tribe saying that no, LLMs cannot think. LLMs can run your own business, or no, because they are, shitful, and so on and so forth. So what I think is kind of the right approach to kind of stop this intellectual madness is actually to dive into facts, into what we know, into the mechanics, and analyze the trade-offs, analyze the things that are not necessarily 0, 1, black or white, kind of binary things, but there are lots of nuances and there are lots of things that depend on some factors. There are pros and cons on everything, etc., etc. And for instance, people say that, hey, prompt engineering is a thing. Other people say, hey, prompt engineering is dead. Context engineering is a thing. Context engineering is dead. Spec-driven development is a thing. Spec-driven development is dead, and so on and so forth. So my kind of suggestion, my preference is to dive into internals in order to understand what is going on, what are the trade-offs, what are the limitations, what are the advantages that we can take of a certain technology. So we're going to leave out, the answering the question whether LLMs can think, but we're going to take a look on how do they work internally. Now, I'm also going to kind of debunk some myths. For instance, some people in social media or whatever, they say that, hey, you should always say that, you're an expert in, I don't know, React, or you're an expert in .NET or in JavaScript or whatever. And automatically the code is going to be better. So we're going to work on that to see like how much is that true. For instance, if you tell a model that the model should behave as an expert, does it increase the model's knowledge? And if it does increase, if it affects the model's output in a way, what is the way? How does it actually affect it? Or there was also a very kind of, hot topic that you can, hire, or you can create an army of agent that is supposed to, make a lot of money and replace all the employees of your one-man company. Yeah. And that's quite often a reason that somebody is basically, listening or kind of following a AI shaman, which I would also like to kind of fight in this talk. So one more actually myth to debunk. When somebody says that the agent follows prompt instructions, like this is wrong in so many ways. First of all, it's not the agent that does anything with the prompt apart from just passing it through, right? It's the model, first of all. And then there comes the question, like, what is the cognitive abilities, or what is the way that actually models can interpret a task, and what does that actually mean to follow the instructions? How does that work? So we're going to work on it. And yeah, why would we even speak about internals? Now, that's a meme that maybe you know it, maybe you don't. It's it's a part of a street interview with some elderly Polish women who've been asked like what do they think about marijuana? And they said like, oh, who needs that? Like, why would you even do that? So basically, you can always ask your question like, why would you do that? Like, who needs that? That's what they said essentially. So who needs to understand, AI internals? So my answer would be that, first of all, it will be way easier for you to kind of differentiate between some false promises and total, sorry to say, bullshit around the topic and the things that actually can make some sense. Not to mention that LLMs, fortunately or unfortunately, are non-deterministic. So it's not a black box that you put an input and you get a deterministic output that would be the same each time. Like, we could make it this way, but it doesn't make sense too much, and we are going to speak about it. But still, yeah, there are lots of things that you will basically be able to differentiate what could make sense and what not. So yeah, my name is Tomasz, and first of all, I'm a software consultant, architecture consultant. I help companies in overcoming software-related issues that relate to architecture, teamwork, team cooperation, performance, testing, and so on and so forth. So quite recently, I have done a big online training related not only to AI, but mainly to AI called Developer Jutra, but there is also upcoming English version called developeroftomorrow.com. But still, my background is software, and for 2 decades, I've been working on that. So let's start, dear everybody. Let's say the story about LLMs and agents from a metaphor. So there is a person, a guy, who is a courier in a transportation company. So basically, this is going to be a metaphor of how does the agent and the model cooperate? Because sometimes when you read or listen to some some talks, some content about AI, people do not always or don't do at all differentiate what's the responsibility of the model, what's the responsibility of the agent, where is the boundary, and basically why should we why does it matter, what should we care about that? So this guy is the agent. So basically, there is a car that you can see in the background. So there is an incoming request to the agent, let's say saying like a prompt. Now, I would like, to please, dear model, give me a recipe for pancakes, or I don't know, code me a little bit of React components or whatever that is. So basically, what's important is that the agent grabs the prompt, the request, but the thing is, the agent doesn't read it, right? So first of all, agent has absolutely nothing to do with any kind of interpretation of the prompt whatsoever. Now, there is a small black room, black or actually very, very dark, and there is pretty much no, connection to the outside world, right? So this is where the model sits in. Model is, well, we could say quite intelligent or very intelligent, but it has no connection to the outside world, despite, like, apart from or except for this small window that is there, the context window, obviously. Now, what the agent is doing, as you can see, he's got his eyes closed all the time, is that he basically pushes the package into the model. The agent has no idea what is it about. So the model gets the prompt, he's analyzing it, and now the thing is, at some point, like, this is a text, right, when it comes, but the model is going to translate the text into basically numerical representation. We could say that it's a binary representation, but all in all, this is basically lots and lots of numerical matrices. So lots and lots of arithmetics. So the model is basically analyzing what is going on there, and he is generating a short response very quickly in a numerical format as well. And at the very last step, this numerical answer is going to be dumped into a human natural language back again. And basically, this response is going to be pushed back into the agent. The agent is basically getting the answer, right? Now the agent is going to put that answer somewhere on the shelf. So it's going to remember or store it in what is called long-term memory. So basically, when you're walking into a applications such as Gemini, ChatGPT, Claude, Com, whatever, essentially, then what you're going to paste and what you're going to type and shoot and what the model is going to reply, like this is a conversation, right? So this conversation needs to be stored somewhere, and this is stored outside of the model, somewhere in a long-term memory. Now, this could be a SQL database. This could be a, I don't know, JSON file, text file, whatever. Essentially, whatever. It could be MongoDB document or a collection, never mind. But still, it needs to store both the prompt and the answer, again, not knowing what's going on there. And then, of course, the answer needs to be passed to the user back again. So the user is typing another prompt again. So another prompt is being received. So what the model is now going to do is that, well, so you have given me a recipe for pancakes, or you have given me what are the React components that I wanted you to code for me. But now I would like you to tell me like how to add a, I don't know, chocolate syrup to the pancakes. Or how could you please modify the React component that is using useState and useEffect, whatever, to switch it to React query or whatever, essentially. So now the agent is going to look for what has been saved so far to what essentially is this long-term memory and put it, like attach it to the prompt. So put all the context. Now, this is not only the history of the conversation. It could be way more things, many, many more things, but at least the history of the conversation would be the smallest ones. So now this package, like extended with the whole context, is going to be put again into the context window or to the model, essentially. Maybe not to the context window, through the context window to the model. So model is going to do the very same thing. And now, as you can see, there is a card over here. Like here, maybe I'll just, highlight it. Oh, this way. Yeah. So there is a card saying what are the allowed tools that the model could use. So the tools essentially is that, if it makes sense for you, dear model, instead of directly replying to the user or to the client who has, sent the request, you might want to search the web. You might want to check what is the weather in your location. You might want to search the news. You might want to check my Docker containers. You might want to take a look what is the status of my SQL database. You might want to search for online tools documentation through Context 7 or pretty much anything. So there could be MCP tools, obviously, but these could be also tools in your agent. Built into the agent, so like MCP tools, but also non-MCP tools. But what matters is that they are just tools. Some of them are kind of standardized through MCP, and some of them are just baked into the model. But anyway, what the model is doing is it's reading the prompt, reading the whole context, and generating a short response very quickly, and sending the answer back again. So in this case, what we can see is that the model has decided that it is going to use one of the tools. One of the tools, whatever that is. So let's say that the model is saying, okay, if I need to, I don't know, switch my React components to React query or provide syrup to pancakes, I would need to first search the web on how to do that correctly or whatever. So now what the model is doing is that it will recognize that, hey, this is not just a text response directly, but this is going to be a technical call, RCP quite often, essentially, but this is encoded using special tokens. We'll see that slightly later. But what the agent is doing essentially is just searching for the first character of the response and searching whether it's a special token of the answer. So, again, not reading the whole answer, but just taking a look at the first token. And if this is a tool call, then it's basically going to walk into what is the adequate tool. Let's say that this is a fax and it's just, shooting some requests further to the internet and receiving the answer putting it into the context back again, putting this thing again to the model, right? So that the model would analyze the answer and send the response to the model, and again, and again, and again, and again, and again. So what we can see clearly is that the content of the box is growing all the time, right? So there is more and more context that is going to be pushed into the model. Of course, at some point, the answer, the response is going to be sent to the user, obviously, right? But the thing is, one of the most important things in modern agentic systems is that this kind of size of the context is growing, and this costs us money, essentially. And if we take a look at this tool call, then there is a, I know how to say it in English, the kind of billing machine that whenever you do something, you're going to be charged for that. So whenever you pass anything through this window, like you send anything to the model, now this will require some electricity, some power to run the model. We're going to take a look what actually that means. But essentially, the more context, the more content you push to the model in a certain request, more power needs to be used, electrical power, to basically fuel the response. So all in all, the kind of golden middle, the balance that we're struggling to find is how to give how to decide what is the most relevant and most significant, most important part of the context without kind of, over bloating the context, right? So that we give only the most important things, but not too much. For instance, if we take a look technically over here, one of the most frequent mistakes that developers make and that I have seen is that, let's say, you have Copilot, you have Cursor, you have Claude Code, you have whatever, essentially your favorite coding agent, and you configure MCP tools. And you forget what are exactly the tools that you have configured. And you have, I know, tens of them, or sometimes even more than hundreds of them. And when you run Claude Code, for instance, and there is a /context command there, now you would see that, oh shit, 1/4, which is kind of 50,000 tokens for most of the models, like 1/4 of the whole context window is just description of the tools, which is, kind of a totally insane amount of waste, essentially, to what we can do with our model. So essentially, not only each tool is going to, run more of these cycles between the agent and the model, but also at some point we should decide what part of the context to drop. And there is, of course, when we want to store information for longer, that also applies to services such as Cursor, services such as Claude, etc. They can provide their own long-term memory. And if you want to store something in long-term memory, their own, or we want to retrieve something from their own long-term memory, we're also going to be charged for that. Of course, it depends on the provider and the specificity of the tool, but essentially we're going to be charged for pretty much everything. So yeah, we want to get our stuff done, but we want to pay the least amount of, the money for running the power of the whole thing. So yeah, let's speak about from technical perspective. So let's close this metaphor and let's speak how does the model and the agent cooperate with each other. So here we've got a very simple piece of JavaScript code. I hope that it's not going to be anyhow JavaScript specific. I hope that we're all kind of, at least in the basics, able to read JS. So all in all, there is basically a sequence, an array, right? An array, a list, a sequence, linked list, whatever this is in your language and your API, no matter what. And basically, what is basically the context that we're going to send? So this is the conversation history, and this, what we can see at the bottom of the screen, is essentially a single call to the model. So when we send a request, then we have this client responses create, and here we put what is the model name, and basically messages, what is the conversation history. Now, this thing is kind of a little bit similar to OpenAI API, but you have a different API for Gemini, you have a different API for Claude. So pretty much all big, or maybe not all, but these biggest vendors, they do provide their own APIs, but still that boils down to the very same thing. So what we're going to do is we're going to use our language to create a context. This is the whole context, and now we need to squash it down to something that would be understandable from a model. So let's say that there is a role system. You are an expert, obviously, right? So this is a kind of a guardrail that would define the model. What are the, let's say, what is the area in which the model can be used, can operate? So this hasn't been used from the very beginning of LLMs, but we're going to get back to that later. So now this is the prompt that the user is sending. So let's say, how should I live? And in the very first turn, that would be what is being sent. So first, system, you're an expert, obviously, and the user, how should I live? So the system prompt is being used as a kind of a technical hack for the vendors of the models, which is being used during the training, so that, let's say, if the system tells, hey, you are a nice person, you never do any harm, and now I, as a user, would like to ask you, like, how do I create a Molotov cocktail, for instance? So the whole point of the system prompt is that there would be a certain amount of test cases in the training data set that would say, hey, if there is a, let's say, guardrail, if there is a rule in the system prompt that says that you cannot do certain things, and I'm asking you for a certain thing to do the violate the rules, then you should answer something like, oh, sorry, I cannot help you with that. Maybe you have some other ideas. So all in all, the system prompt is being extensively used, of course, by us, but also during the training. So that, like, imagine that you train a dog or you train a different animal and you really need it to be, well trained, so that you repeat and repeat and repeat and repeat and repeat. And this way, the model is being trained. Of course, it's not perfect, and therefore we can do jailbreaks. All right, and yeah. So when the assistant answers, "Come on, in peace with yourself and the universe," then the conversation grows. So I was just looking at the chat. So once the model answers, the agent is responsible for getting the things, storing it in, I don't know, files, JSON, SQL, Mongo, whatever. Then going back with the answer, going back to the model, going back with the answer, and so on and so forth. So we could say that the model is responsible for thinking. Now, this thinking is with a big asterisk, because the model do not think, or whatever we call it, and the agent is responsible for running all over the place and preparing all the stuff. And it's difficult to say whose job is is more difficult. Now, the foundation for how models work, models, which is LLMs, is essentially machine learning. And in very, very short, we could say that it's basically multiplying matrices and adding matrices. So it's a really enormous amount of lots and lots and lots of extremely big matrices. So just to make an example, I would like you to show an example model on a hugging face, whatever that's going to be. So here I'm looking at DeepSeek R1. This is the first version of DeepSeek. It's just the first one that popped up in my search bar. And now what is interesting here is that here we have model for DeepSeek AI, blah, 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 blah. And we have adapters, fine tunes, merges, and quantizations. We're going to go through these things. However, what is important, let's say that we'll go to quantization and we will take a look at DeepSeek for GGUF, a pretty, I would say the most important GGUF is format for open source models. And what's important here, we're going to get back here, dear everybody, though, like we're going to cover quantization. But if we take an example quantization, and let's take a look at how the model looks like. And this is what we can see. I'll try to just increase the font. So we have lots of things like, metadata, etc., etc., etc. We have the system prompt. And if we scroll down, and you will basically see very, very, very similar thing to all large language models, small language models as well, but language models, then you will see this part. So we have tensors. So there is a token embedded weight, and now we have these numbers here, 7,000 something something, multiplied by 129,000 something something. This is essentially a size of the matrix, so like two-dimensional matrix, and each cell within the matrix is of this format BF16, and this is essentially 16 bits, which is 2 bytes. So we could basically, do a quick calculation, this number times 2 bytes. And this is essentially the size of this matrix over here. Now, as we can see, if I just collapse over here, we have bulk 0, 1, 2, 3, 4. So there are 5 layers in DeepSeek R1, and the structure could be totally different across the models. But still, each layer includes, again, a matrix. Matrix is basically a two-dimensional set of numbers. Now we have a vector. Now we have a matrix again, a vector, matrix, matrix, etc., etc. So we have all of these in place, and as you can see, they can have different precision. But and essentially, all this machine learning, let's say, art and the science is how to structure these matrices so that all these numbers, when they get multiplied and added and multiplied and added and multiplied and added, so that the output would actually make sense. And as you can imagine, multiplying and adding all these numbers sum up to really enormous numbers of operations. So now the question is, why do we need so many GPU processors, like graphical processing units? Why do we need them? Because something needs to do all this multiplication. And the trick is, it's not obvious to answer the question whether LLMs can think. What you can see here, right now, is that there is a lot of arithmetical operations. And we actually do not know how our human brains work. We have a guess, we have some, models, we have some kind of interpretations, but we don't know how exactly our brains work. We know that our brains are not that regular, like essentially these are neural networks, we're going to see it, but our brains do not work like they're not structured this regular way. Our brain, neural networks are way more irregular. But still, if I can think about something, if I can make fun of something, if I listen to something, etc., etc., we don't actually know how does each small signal goes through my internal, neural network in my brain. So we know how do models work, but we do not know how our brains work. So this is the kind of gray area where we cannot, strictly determine whether LLMs think the same way as human does, because we do not know how we do think. But still, this is an enormous amount of mathematics, so to say. So yeah, there has been some questions on the chat, so that I would answer them. What is the smallest LLM that I can run on laptop for local development? And what is the best model for programming? Serhi, difficult to answer that very quickly, because there are lots of factors to take into account. So first thing is that Models can be more, let's say, universal, or models can be narrowed down to a specific domain. For instance, if you ask a model such as, I don't know, Gemini or Claude Sonnet, etc., they are really gigantic models, and they're trained on quite a big amount of humanities knowledge, etc. So these models are going to be really, really, really big. But for development, do you really need to the model to know about philosophy or about cooking or about, I don't know, ancient Greece or whatever? So all in all, it does make sense for us to provide smaller models with smaller knowledge, but only let's say, restricted to specific technology. For instance, you're a web developer and you do React or Angular or whatever. So you would be fine if the model just understands JavaScript, TypeScript, and the framework, and maybe Linux and maybe Docker, and that's it, and NPM. That's it, but nothing else because it's not needed. So all in all, it's totally different if we speak about, big models from big providers, from big tech, which are creating, really gigantic models such as OpenAI, such as Anthropic, etc. So these are multi-purpose models which are good, but on the other hand, these are really extremely expensive because of their size. Now, if you think about it, such a great model, such as great, I mean very, very big, such as, I know, OpenAI's, GPT, Gemini, etc., they're going to be so big that would be enormously big over here, right? But if you, let's say, take a small model that would fit into 2 gigabytes, you could not fit all the, all the knowledge that Gemini or Claude Sonnet has. So yeah, it's a question. Whether we go the big tech way, which is kind of impossible to put on your own laptop, or to choose smaller models. Now, there is something like, for instance, Qwen 3 that is supposed to be one of the best for local coding, but the problem is, and we're going to get to it, is that you have a, let's say, source model. Like here we've got DeepSeek. Let's say this is, of course, just an example. Let me just, zoom it out. So DeepSeek R1, but on the other hand, as you can see over here, this DeepSeek is going to be kind of compressed, squashed into smaller versions. And now, if you, for instance, want to run Qwen 3 on your laptop that is quite limited, most probably you're not going to fit, like, as you can see over here, 1.3 terabytes of virtual RAM. Imagine, not 1 gigabyte, like 1.3 terabytes of RAM. Now, you would run a smaller version, but still 400 gigabytes, still quite a lot, isn't it? Now, you could run, let's say, 169 gigabytes. Maybe you have, the biggest Mac, or you have a biggest, I don't know, quite a big GPU unit, etc., etc. So you would need to calculate the thing. And essentially, if you want to get a kind of, how to say it, a oszacowanie, estimation of what would be the model, you can just ask. By the way, I could ask the model over here. Please estimate how much RAM memory I should get, how much virtual RAM memory I should get to run DeepSeek R1 according to this spec. And now you can essentially see what the LLM is going to analyze. Oh, sorry, that's in Polish, so I'll just ask it to rephrase that in English. Yeah, just please stop, and I'll just answer in English. And that's it. Yep. So this will tell you more or less how much RAM do you need, but this is not about RAM. This is virtual RAM. And all in all, these are going to be quite big numbers, very, very big numbers. And if you decide, okay, so I'm not going to use the best quality because it really requires a lot of devices and resources, you would run something that is smaller, then the quality is going to be so much penalized that I don't think that it's worth it. So we are kind of in a border on the line where it's not yet very effective for a regular developer to invest in their own GPU because it's first kind of experimental and second, it's really expensive at this point. So I would say it would be probably more, it would make more sense for you to use the models from the providers because you don't need to put the whole investment into the GPUs or a very expensive, hardware at this point. But still, what's important is that there is a, let's say, hope, a very big hope. So basically, what is important? We can take a smaller model, and instead of going to the direction of the big providers that are going to, teach the model about everything in humanity, let's just only train the model on specific technology and maybe the surroundings of the technology. So for instance, teach it HTML, CSS, JavaScript, TypeScript, React, or Angular, or whatever, and that's it. And your model doesn't need to have, as you can see over here, it doesn't need to be as big that it has the number of parameters that is so big as we can see, as we can see over here. Yeah, we have over here 685 billions of parameters. So what does that basically mean? When we remember all these matrices, each cell is just one parameter. So if this is almost nearly 700 billions of parameters, and each of these parameters takes 2 bytes, then you can quickly calculate how heavy the model is. So all in all, there is a light, there is a hope that basically we would be getting smaller models, teaching them specific technologies so that it would make more sense and it would be more effective for us to basically download an open source model that could be based on Qwen or on Kimi or K2 or DeepSeek or whatever, essentially, right? But not the gigantic, super big Gemini, super big Claude, super big GPT, etc. We don't even know how many models they have. The vendors stopped telling us how big those models are. Until some point, they have been saying it, but now they don't. So we don't even know how big they are. But we can only assume that they are really, really big. But again, think about it. If the models from big vendors are so big, so they need to go, let's get again to this quantization. They need to go through all these, maybe not always, but quite often. They need to go through all these stupid layers, right, over here, to do the calculation. Imagine if you just need one simple answer from your model, and the model is super big, it is quite probable that the model would either need to go through all of that or at least a big chunk of that. And you don't need that always. But the thing is, so what we should do, we should take a smaller model, train it on a certain technology and profit. But the thing is, doing that, it's not easy. And who is going to do it? Well, we engineers could. But who is going to pay for it? And that's the problem. So there needs to be some community heroes, open source heroes, who are not only kind of, proficient in machine learning, but who would also pay with really, lots of dollars or whatever other currency to basically do that training, because this is going to take a lot of effort. And also, if you want to have a specific technology, then you would need to go through, gather a big data set. For instance, if that was React, you would need to go, okay, so here is a pattern that I like to do. Here is a anti-pattern that I don't like to do. And again, here is a pattern, an anti-pattern, etc. So all in all, you would need to provide the data set that would be at least hundreds, if not thousands of prompts that would be high quality. And imagine, who would create high quality, thousands of high quality prompts and high quality expected answers? That's the challenge. And now big tech has got money for that from VC and open source. And that's the problem. So there is a clear path to go, which is good, but it's going to take a lot from here. So sorry for the long answers, but all in all, it was a very good question. But, I could tell you, well, you can try Qwen 3, but it's not going to be that easy. You need to have a really big, really strong hardware. Most probably, you're going to pay a lot for it. And if you just stick to current vendors, this is going to be simpler and cheaper, unless we get to the point where open source coding models, small technology-specific coding models are there, which I believe is going to take a couple of years. By the way, if we analyze the history of open source, etc., we can see that we used to pay for databases, we used to pay for operating system, etc., and now it's all free. We pay for infrastructure, obviously. Infrastructure, I cannot think of infrastructure to be free totally, or at least not during our lifetime, but software is free. Infrastructure is not. So I believe, right now we are paying for the models, but I hope that within some time, it should be possible if you have, 64 gigabytes of virtual RAM to basically fit a coding model there, but we're not there yet. So you can take a look at Qwen, which seems to be the best, but for most use cases, I think it's going to be a foot gun. It's going to cost you more than it's worth. It's okay to experiment, though take a big grain of salt when it comes to it. Roberto, can we say Claude Code is more an agent than a specialized LLM? Claude Code is absolutely an agent. It's a coding agent. Now, what is the LLM? By the way, I'll just open a console right here because I can just open Claude. So when I run Claude, then this is a Claude. Claude. Oh, damn. What was the command to run it? Okay, never mind. We can use Gemini. Something could have broken here. So basically, whether it's Claude, whether it's Codex, whether it's Gemini, whether it's any of these other things, now you can choose which models you're going to use. For instance, here I can choose between, Gemini 2.5 because it's a free tier, or manually using any other of these models. So all in all, the program that you're using is the agent, is the coding agent, and there comes a model. And now this model can be from single provider, as you can see here, Gemini, CLI, well, it consumes Google models. Claude Code is going to use Anthropic models, etc. There is open code, for instance, an open source coding agent who allows to use. Oh, this is archived. Never mind. That's just a old link. A coding agent that allows you to bring your key to various, vendor, etc., and use it. And for instance, there was a big shitstorm when Anthropic said that you cannot use Anthropic models on behalf of custom, other coding agents. So yeah, Claude Code is definitely an agent. Now, Dmitro wrote 200 billions of 700 params are synthetic, as we can already have the whole existing internet knowledge in one model. Not sure whether it's a question or whether this is a statement, but it's difficult to discuss whether something is a whole internet knowledge. I believe it's not possible to fit it in such a small amount. But the other thing is, not the whole knowledge from internet is useful or is valuable enough to be put in a model. Like, I don't even mean, things like propaganda or kind of, censorship, etc., etc. But some things are just, literally rubbish. So this is also, in machine learning, this is also a pretty big challenge. How to decide which amount of knowledge is worth being put into the training or not. And maybe one last question. Can we combine small LLMs specific into one, or we need to create own? Okay, so it does make sense. I was going to target it slightly later, but in very general, you can take a model that is, for instance, this 700 nearly 700 billion parameters. And yes, you can squash it into a smaller model that would have way less parameters. And I don't even mean the size of each cell. I mean the number of parameters. So you can do it. And technically, it's absolutely doable. For instance, we have a Polish model called Bielik, just like an eagle, white eagle. And it was based on Mistral. And it was bigger. And then it was kind of, kind of reshaped. You can reshape the tokenizer, you can reshape the model itself, etc. Though all the things that are related to this reshaping of the model are just going to make the arithmetical things, the work of the matrices, more complex. So it's absolutely doable. So it's going to be adequately more complex when it comes to this, mathematics. So yes, you can do it, but it's again, machine learning and algorithms and Python and all the tool stacks in Python are probably the dominant. So okay, let's continue just with the most important things that I want to say in the presentation. So all in all, we have a user that shoots a request to an agent. So for instance, what Roberto asked, Claude is more an agent than a specific LLM. So yeah, you as a user, Roberto, are shooting a request to an agent. Now the agent receives the request and it will pass it to an LLM. Of course, you could, for instance, ask, could the agent cache a response for a certain question? Technically, it could. Most probably, it doesn't make sense, but technically, could it do it? Yeah, why not? Because an agent is just a program. For instance, you have databases, you have files, etc. So an agent is just a program, like just, obviously. But as you have seen, at some point, the LLM decided that it's not going to answer directly to the user, but it's going to use a tool. So the thing is that there was a loop between the model who decided to use a tool. Now the agent is going to run the tool to get the answer back to the model, and then the model could use a different tool, which the agent needs to run. And then gathering all this stuff so far, the agent needs to put, okay, so this is what you wanted. Now this is what we've got, all the things so far. So this is what you've got. So now the model needs to decide, okay, so what are we going to do next? Ask one more tool. And, ping, pong, ping, pong, ping, pong. And the context grows, right? So this is the agentic loop. But as you have, as somebody has pointed out, probably it was Dmitro with this statement about number of params. At some point, like the model has a limited capacity, so it cannot have all the knowledge in the training data set, right? So there is a knowledge cutoff. Most probably you have heard about, knowledge cutoff in the era of GPT-3, when GPT said that the knowledge that it has stops at something like September 2021, something like that. And there were no tools at that point. So what is the solution to the problem? By the way, agentic AI is all about problem solving, which is kind of super and really enjoyable. So retraining the models with the most recent information is damn expensive. Really, really, really damn expensive. So how could we overcome the problem? By introducing tools. And that's the point, right? So the LLM is going to ask for a tool. The agent is running some various stuff. The agent is receiving the answer, going back to LLM, etc. And this is the agent loop. Now, at some point, LLM is just going to decide, okay, I have everything. I can make a decision. So I'm just going to reply back to the user, which is the final kind of, final answer. Of course, final answer for a single prompt. Now, what could it be? This could be just browsing the internet, obviously. This could be accessing whatever, services, digital services, databases you've got. Your local files, by the way, when you're using Claude Code, Gemini, Codex, whatever, they are reading your files. But they're also writing, modifying your local files. What are these? Tools. So there would be a read file tool. There would be a write file tool. So imagine how many tools the agent needs to understand. For instance, if the prompt that the user is saying is, hey, please modify my React components, then the model would know, okay, so the user wants me to modify the files. So first I would need to run, for instance, ls, which is list the content of the directory. That would be the first response. Then another one, please give me the content of the files, blah, blah, blah. Only then the model would start processing whatever you wanted to develop or program or code. And only then, after some, doing some thinking or whatever we call it, reasoning, there would be an answer. So there is a very, very big loop over here. Now, so what are the tools? First of all, a read file and a write file. It's not an MCP tool, right? Because why would it be an MCP tool? Because it's not a, standard kind of thing like Postgres or Mongo or Docker or Kubernetes or whatever. Read file, write file, git commands, etc. They're just going, or just invoke a shell command. They are just tools built into the agent, just custom tools. But the model doesn't care whether something is a MCP tool or internal agents tool. They're just going to call it. Now, if we have this, model context protocol, the whole thing is that an agentic app that is accessing the model itself would like to use an external service, but this way the agent would need to know how to access Docker, how to access SQL, how to access Mongo, etc., etc. So that would be kind of troublesome because each agent would need to provide, like agentic application, would need to provide lots of adapters, really lots of adapters. And we remember that each tool that is being provided costs a lot. So that would be kind of, difficult to maintain. So what's the point? There is an intermediate protocol, like this model context protocol. The name is maybe not the best, but still, we can, allow an MCP, we can create a server that is basically going to proxy, is going to facade a real service by allowing us tools so that basically the agent is going to collect all these tools. So create a list. So it's going to create a list of all the MCP servers that are being collected over here, plus its own tools, and say, hey, dude, these are the tools that you can use. But what is important here a lot is that if you put lots and lots of these, they're going to consume a lot of context, right? Which is going to be quite painful. So all the thing to everybody is how many tools would the agent need to have if that was basically a pure RAG, retrieval augmented generation, or if it's just a simple MCP client. MCP client is just one to rule them all. So we could say that MCP is extremely useful for coding agents. So that was one of the solutions, to introduce some flexibility in the ecosystem, right? So that every service can be, facaded by an MCP server. But what is also important, don't think of MCP that it's useful to have MCP over everything. For instance, MCP over Docker, MCP over Postgres, MCP over Oracle, MCP over Prometheus, Loki, Grafana, whatever. Why? Dear everybody, because if I have a Docker running over here, And I have some containers over here, never mind. What I can do always, right, is I can write Docker, Docker. Oh, by the way, I need to remind myself. Yeah, what's the command to list Docker containers? I guess that's but the Docker ls, Docker container ls, Docker ps, Docker ps, Docker ps minus a. And now I can see all the containers that I've got here. And now what do? I just shoot a shell command. Now, am I using MCP? No. And now imagine, dear everybody, if I'm just going to jump to one of the previous slides. Now, the more things, the more tools I put to the list, the more context I'm going to use for every single damn prompt. So putting lots of tools in MCP costs me money, essentially, right? And now, if I want to use, let's say, I want to search for what is going on in Docker, or let's say that I have a Postgres container, and this Postgres container does have the ability to run, Postgres command within the container, or, replace Postgres with anything, right? With whatever that is, right? But still, can I run, I believe it was called Docker exec minus t, and here comes container name, I believe. What was the name? Postgres TMS Postgres container. Yeah. So then I would say PSQL something, something, something. And now, as you see, can I run a command to the within the container to whatever service I have locally, whatever service I've got externally? Can I do it? Yes. So now the question is, when does it make sense, dear everybody, to provide MCP servers? I don't mean even writing our own, but when does it make sense? If I can run a shell command, I just avoid MCP as a whole thing, right? So this is super useful that this is a tool, right? But still, how expensive is it going to be for a model to decide to make a local, shell command? Now, what is a tool? There is a tool in each agent, which is basically called shell command, execute shell, shell exec, whatever we call it. And instead of having a, specific Docker MCP, specific SQL MCP, specific blah, 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 if there is a possibility to just directly run a, a shell command, just do it, right? And I'm not going to say that MCP is dead. No, MCP is not dead, and it's not going to be dead. The thing is to everybody to put as little context as possible. And by the way, here we've got a screenshot from Cursor ID, I believe, and you can see basically that I have put some of the files over there. And here you can see the 16.6%. So this is the size of the window. This is the context window. So it's not only my prompt. It's not only these files that are being put here, but it's also the whole history of the conversation. But what else apart from that? If we take a look at other things that I'm going to, just need to close it for just the time being. We are going to also take a look at, for instance, in Cursor and all other things, we have settings where we have rules, skills, sub-agents, tool and MCP, etc., etc. So what is all this, dear everybody, context over here? It's all these things put together. So when you're thinking about development in practice, I would say, at least at this point in 2026, the most important rule would be to verify what really needs to be put in the context. Because let's say if you provide a rule, just a cursor rule. So for instance, MDC file, and I have, there is some Polish stuff, never mind. But what people often do is that, let's say, how to use Docker correctly. That would be the file, right? What I mean is that take a look at how this file gets long because, oh, that would be such a, good book about Docker. And imagine if that was the rule, and it would also have this, as you can see over here, apply always true. What that means that this rule would be, this file would be applied every single damn time to it. And now, if we also make fun, and we take a look at tokenizer, OpenAI tokenizer, online tokenizer, tokenizer, OpenAI API. Oh yeah. So this is just an example of OpenAI tokenizer, and it really doesn't matter whether it's GPT-5, whether it's Gemini, Claude Sonnet, etc. That's the part where I meant that the text is going to be dumped into numerical representation. So in case of this tokenizer that is used for these exact models, this file of useless 630 lines of Docker description, whatever that is, would give 8,500 tokens. So that would be out of 200,000 tokens, that would be kind of 0.5% each of the whole context window, each single prompt, right? So imagine how many things you probably put totally unnecessarily to your prompt. Now, what is this thing over here? Again, let's try to everybody to go back to the piece with the code. The coding agent needs to put all the knowledge about your coding, about your files, about your rules, about all the other things. It needs to put it in some kind of structure. We can think of it, simplify it to this kind of structure, like it definitely they're using their own API, but for performance, for vendor locking, etc. But it would need to have some kind of structure like this. And the whole thing is that the more things we put here, the more we're going to pay. And what would be a kind of rule of thumb? If you're going to, let's say, if you're working on a specific thing and you have finished quite a big amount of work, either reset the context totally, which basically would remove all the things from the context, which means what? That array would basically got cleared. Or you can just start a new thread, which essentially boils down to the same thing, right? But what you should matter about, and right now, and beware, like, are the vendors interested in you consuming the least possible amount of tokens, or are they interested in you burning as many tokens as possible? Now, this is a rhetoric question, right? So you should be responsible for being aware of how many tokens you're basically burning, right? So just as with, modeling, backend architecture, etc., think about small modules, think about small interfaces, think about small objects. Don't think about, don't create God classes that have hundreds of attributes, right? Because they're going to be really difficult to maintain and to work on. And now create small threads. Do a very small task on a single thread and either reset the context or just start a new context, etc. Because if you create lots of small threads, then your context is going to be smaller. And now the thing is, you could think, on one hand, and let me just open something over here. You could think this way, 200K, I'm just going to draw it. Let's say this is my context window. So let's say I'm making one shot for, let's say, that would be one prompt. With this amount, one prompt. With this amount of tokens. So that's one thing. Or we could have, dear everybody, let's say 10 prompts, and each of them would be, dear everybody, 10K. Now, what is going to be cheaper? This one. So all in all, we could say that, of course, it's a simplification and it's difficult to get there. But as a rule of thumb, and what is very important here is that we should pay attention, and what we should minimize is the amount of token consumption. And why is that? Because if we have all these matrices and we put the text, then our text, dear everybody, is going to be put into these tokens over here. And now these tokens are just going to be displayed as IDs in the tokenizer, in the dictionary, it doesn't matter, but they're just going to be a sequence of numbers, essentially. And now these sequence of numbers are going to be processed by either all of these layers or most of these layers. This also depends on the architecture of the model, but they're going to be processed there. And the thing is, the shorter your prompt, the less processing. The longer your prompt, the more processing you've got there. So all in all, let's say our kind of gold medal should walk through shooting bigger number of smaller prompts that would take less processing because it's going to be cheaper. And now the thing is, are you going to do your work in one gigantic prompt? Probably not, because you will need to verify something, you would need to iterate with the model, you would need to fix something, improve something. The model probably didn't look for something, etc., etc. So most probably you would need to iterate, right? So most probably that would not be one times prompt, 150K, but that would be more like 3 prompts or 5 prompts. And now the difference even starts to get bigger. And how do most effective coding, not coding agents, all agentic AI work, is that they try to make as much as small calls to LLMs as possible. By the way, we are not being charged per requests. Can you remember Cursor used to charge us per request? They used to, but they're not anymore. Lovable used to charge per request no matter how big the request is. And now, not anymore, right? So essentially, we're going to be charged for tokens. And this depends on how big the prompt is, right? How long, according to the tokenizer. And essentially, to everybody, our effectiveness, of course, depends on how precise the prompt is. But we should not put too many things there. And also, the bigger the model is, the more expensive it's going to be, right? So yeah, the last thing that I would like to show you, and this is something that, again, model vendors do not speak about, is that when we have this conversation, let's say that there is the user, I need to help with my order, assistant, I would be happy to help. Could you provide your order number? And here comes, yeah, it's order 123. So what's going on here? There is a user turn, there is an assistant turn, and there is, again, a user turn. So what the model is going to take, right? So the agent, well, it's not the agent itself, it's basically the entry level to the model. It's going to, dear everybody, be, this is the API that replaced that, hey, this was the user turn, that was the user turn, this is the assistant turn, and now it's again the user turn. So there is a system prompt. And take a look at this. What's the thing? I am start, I am end. This is a special token. So it's not like, a token that would be like, what are the tokens basically? The tokens are these things. So, cutting our natural language into parts. So let's say, for instance, here, Postgres is 2 tokens. Postgres. Or generator, as you can see here, generator is 1 token. And A was 1 more token. Or output is also 1 token over here. Because it's just probably a frequently used word in English language. Now, this is a single token. And the thing is, if I have a special token, the model needs to be trained on that. So at some point, models did not have system prompts, but they were, so there was a special token introduced and it had to go through all the training, right? So that models could answer, could interpret what is the system thing. Now, there is also I am start with user, I am end. So it's basically a kind of a boundary for parts of this conversation. And again, we have assistance. So this way, using this special token, these special tokens, I am start and I am end, this is from some open source model. This way, to everybody, we can verify actually, like the model knows where is the start of a certain thing and where is the end of a certain thing, and when the next part starts and when the next part ends. And again, think about it that after introducing this structure, the model is retrained, let's say, 1 billion times over all data sets with this structure. After 1 billion iterations, the model will know how to interpret the thing, right? So it will know how to understand. And now, when we ask something, the thing is, we have given the whole conversation a So by the fact that I have put this at the very end, so this is what the API is doing, API of OpenAI, API of Anthropic, of Gemini, etc. They're doing something like this. AI is all about problem. Uh, Agentic AI is all about problem solving. So before we, well, we'll see how much time do we have, but let's go to the through the comments again. So yeah, Alexander asked, if I had a research conversation with model and after some time I returned back to this conversation and asked one more question, how does it work in continuing conversation? Will the whole history be sent to the model again, or we have something like model state? Alexander, it does depend on how the in how the agent is being implemented. And in open source software, we can basically verify how it's being implemented. But with closed providers, we don't know. But what could change? First of all, if the time has passed since your research, then the question is it the same model that you would continue with? So that's the first question. Another question is, there could be some compression. Now, I'm not sure if we're going to have time for that, but all in all, imagine a situation where you have a long conversation, user assistant, user assistant, user assistant, blah, 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 and it's just too long to fit into the context window. What can we do? We can basically truncate the end, but it's not a good idea. We can persist and pass only a part of it. By the way, have you ever found a situation where you have a long context and at the end, the model forgets what has been said at the very beginning? Lots of people have experienced this thing. That's because it's basically too long. And now, one of the many things that the agent is responsible for is basically, if I have, let's say, 200K of context window, how can I fit something that is bigger into the context window? So maybe I do truncate, maybe I just pass only the most recent part, maybe I compress, maybe other things, right? And by the way, for instance, Claude Code and Gemini, etc., they have specific commands. Please compress my context, right? So don't put all the things, just grab the most important part. So let's say if I have the context from 200K, just do it 20K, right? Compress. But this is a loosey compression, right? I do lose some information, right? But yeah, that's the problem that we have. So Alexander, there are many things that could affect this. I would say one of the most important things is that if you have a deep research tool that you're using, most probably after some time, you're going to interact with a different model. So let's say that there is a conversation between, I don't know, your wife and her mother, or I don't know, right? There is a conversation, and this conversation is stored. And now there would be a different model. Now you should continue this conversation as you've been speaking, but what have been speaking was said by somebody else. So in other words, one model has started saying something, and now a different model needs to continue. This could be awkward. So that's one thing. Another thing is that this model could have a different context window, or maybe that was compressed in a way. For instance, imagine that there is a lot of this long-term memory to be stored. And now, if you are Google, then it really doesn't matter if you have, gigabytes or terabytes or petabytes of data. Google can handle it. But if you're a smaller provider, then probably this, long-term storage costs you. Like, Amazon S3, Amazon Glacier storage, etc., these kind of things. So it's probably, expensive to store this kind of stuff, right? So most probably the vendors would like to compress this data that they are storing. It's just, textual data or binary data. Maybe they compress it, maybe they uncompress it. We don't know. But essentially, there are lots of different technical things that could affect of what actually is going to be the context that you send. So there could be different answers. But also remember that if your conversation is too long, then at some point the model is going to start forgetting what was at the top. By the way, on the other hand, if you're using Gemini, Gemini is supposed to have 1 million tokens in the context window, which is really, really, really big. So what is nice about it? It's less probable that the model would start forgetting things. It's nice. The thing that is definitely not nice is that it's killingly, deadly expensive. And one thing that you should know, dear everybody, that the complexity, the algorithmic complexity of going through that thing is not linear, it's quadratic, it's square. Sorry, not quadratic, it's square. So n to the power of 2. So for instance, if I'm going to have a, let's say, a context window that is 200K, so that would be, let's say, X, right? So if I wanted to have a context window that would be, let's say, twice of that, then it's going to be 4X. Because if it's twice as big, then this is going to be 2 times 2. So all in all, when vendors say that, hey, we're going to put, like they used to say it 1 year ago, we're going to put bigger context window and bigger context window. No, you won't, because this is going to kill you, effectively from the perspective of money. So no, you're not going to do it, right? And as you can see, like maybe I'm not up to date, but I haven't heard about any model that has a context window that is bigger than 1 million tokens, which is still kind of insane and extremely expensive to run. Yeah, another question. Can agent decide, Andri, what model to use depending on context? For example, call one model for coding and another for cooking. Yeah, definitely. For instance, a very kind of useful thing that I would suggest is that, for instance, when you're using Cursor, it's just an example. You have, let's say, strong models and weak models. And Composer, something that is built into Cursor and is they say that this is a Chinese model that was fine-tuned. Fine-tuning is basically kind of retraining, adapting a model through further, phases of training. So it's Composer is said to be, I'm not sure whether it's Kimi K2 or whether it's Quen, never mind, a Chinese model that was fine-tuned. And these are supposed to be really, really, really cheap. And when we walk into plan and usage, you will see that I've got separate thing for auto plus Composer. So basically the cheap stuff. And the usage here is really big, allowed. And API is basically, Claude Sonnet, Claude Opus, etc. So here you hit the limit very fast. Here you hit the limit very slowly. But Composer is definitely way worse than Sonnet is or GPT Codex, etc., etc. So all in all, Andri, if you have a task that requires taking many things into account, like, really good quality, like planning, take a good model, a strong model. And now if the plan results in, dumping, you should do this, and this, you can just slice it into smaller parts and give it to Composer, and it does make sense. But you're just going to pay less for it. So it's basically about cost effectiveness. Roberto, what would be the difference between quantization and distillation? I may be mixing something to make a model smaller, and what is needed to transform LLM into LRM? I believe it's a maybe you meant um, so if we take a look at quantization, where do we have it? Oh yeah. So basically, we have a model that is quite, let's say, big, right? That is quite big, and we would like to make it smaller over here. So we've got these 700 billions of parameters. That every parameter is 4 bytes or 2 bytes or 1 byte or even half a byte, like 4 bits only, right? So imagine how degraded the model is. And by the way, when people in internet compare how precise a model is, when you run your local models, or you at least choose a model to run, for instance, via OpenRouter, open source models, you know which quantization, which version you're running, which is good. You at least know like whether you're using, what kind of engine for your car you're using. But if you're running, for instance, let it be, Claude Sonnet, we have no idea what is the quality here, what is the quantization. By the way, if anybody here has been using Claude models, and I believe you have been using it to some extent, you might have experienced a situation where Claude models are really good, really good, really good, and suddenly one day the quality drops so dramatically, so badly, that the model for a few hours, for instance, becomes totally useless. Dear everybody, what is the reason? Quantization. Now, the reason why the company decided to do it, or there could be multiple reasons. There could be, of course, like, reducing the cost of the runtime, the cost of the infrastructure. There could be some kind of infrastructure problems or kind of fallback, some kind of, temporary issue solving, or kind of, rerouting some requests of some users to some other models, etc. But the problem is here, you have no idea what quality of the model you're running. And as long as this is paid, you're not going to know it. So I would say here we are in the era of Windows operating system 20 years ago, or 25 years ago, or even more, where we had to pay for that, and there was essentially almost no alternative. Now, today, operating system is free. All we pay for is basically hardware or electricity, right? So I believe like if AI is going to share like what has happened in history, then it will change, but probably it's not a matter of year, more a decade or 2 decades. But I believe that at some point, basically, there would be more and more of good quality open source. And basically the providers would, just as we have with cloud. By the way, do you pay for Kubernetes? No, you pay for the cluster, for the infrastructure, for the hardware, for the power, for electricity. Do you pay for software? No. So I believe like it will take long time, but we're going to get here. So all in all, when it comes to quantization, we don't know what is this, but when it comes to distillation, well, that's a bigger topic, Roberto, maybe for a separate discussion. But still, it does make sense to get a bigger model, retrain it, like fine tune it, and dump it into smaller model. But yeah, this all kind of trainings and fine tunings. This requires a lot, not only knowledge and experience, but also power and electricity. And this is just expensive. Andrei, or is it possible to have a kind of orchestrator agent that communicates with different other agents and summarizes the answers? Yes, absolutely. So this is maybe not very popular, but there is something that is called A2A, which is agent-to-agent protocol. Google-based, where you don't route between various models, but you route between agents that are specialized in stuff. So you could think of it as a kind of distributed system, but not distributed databases, but distributed services. So you can think of it as a metaphor of big distributed microservices things, where each service is doing their own stuff and they communicate with each other. So there is as you can see, there is a protocol that enables communication and interoperability between them. But yeah, this is so yeah, technically yes, but this is when it comes to, application in business, Andri, this is a quite early stage of this. Yeah, there is also a trending idea to replace MCP with CLI commands, Vitali. Yeah, just as yeah. Andri, is there a way to cache the context, not to include it together with each prompt? Andri, so this is carrying on with your question. Also, is for the purpose of breaking the process into smaller pieces and planning possibly was introduced. Yes, absolutely yes. Absolutely yes. So you can think of it also that if you take a strong model like Claude Sonnet, and it would basically spit out a plan file. So first of all, different models and different requests can grab these things, but also think of it in a slightly different way. Don't think of a coding agent that would, or model that would generate one file with a plan, but think of a model that would create actually a plan that includes 4 or 5 or 10 smaller files. And then we could go even further in this direction of breaking a big thing into smaller steps. So yes, absolutely. But the thing is, models are non-deterministic, that's one thing. And the other thing is that we need to, go like machine learning specialists need to go through this part on how to create training data sets that would take a big task or your big problem that you as a user prompt, break it into smaller pieces so that it would not only be correct, but it would also be token effective in terms of further requests to the model to accomplish the whole task as a whole correctly and more effectively. So what you're asking about, Andrei, makes perfect sense, yes, but it's not obvious to do. But the area that you have drawn, yes, absolutely. And we could say that the more effective you are in the area, it makes, let's say, tools as Claude Code and Gemini, etc., more effective, and you feel that you pay less with tokens and you get more value. So yeah, absolutely. By the way, one more thing here that is important. Imagine this is what the model gets from our prompt, right? This is exactly what the model gets via the API. And is it possible that, let's say, Anthropic or Google or OpenAI or whatever, a model vendor, AI vendor, would provide a new separate, let's say, custom token that would have a, let's say, specific meaning, some new semantics. By the way, I'll just work for the tools. Yeah, something like this. Start header ID, end header ID. And let's go further. I have a tool call, right? So now, can you imagine when a little bit over 1 year ago, Anthropic has introduced MCP, Model Context Protocol, and that was like, wow, how wonderful is that? Now, that was really a big step forward. But still, look at this. It's my turn, then it's somebody else's turn, and now the assistant answer is to call a tool, right? And now imagine, if I am a cloud vendor, can I think of really good idea that would require a new custom token. And now I would have to retrain my own models in my own infrastructure, and I would code my own coding agent just as Cloud Code so that only my tool can use this new capability only with my models. Right? So it's not only about the model, it's also about the coding agent that would be allowed to do it. And this is essentially what happened with MCP and tools. So most probably it will happen again at some point. But the thing is, with closed providers, we have no idea what's going on there. We can just guess and try to recreate it in open source, right? Like open source is going to win anyway, but yeah, it will take time. So all in all, if you're a big vendor, your, let's say, advantage is that you have the whole ecosystem, right? You have the coding agent, but you have also the models, not including the other things. And imagine the breakdown with Cursor more than half a year ago when they increased pricing. Cursor was cooked because they had only the coding agent. They didn't have their own model, and they were cooked on this level. If Anthropic increased the pricing for them, Cursor was doomed, right? And what did they do? So guys, we need to create our own models. And here you are, because now you have an ecosystem, not as strong as Anthropic, but here you are. Yeah, so you use start and end to create a mega token. No, it's not a mega token, it's a custom token. And yeah, there is a token for starting something and there is a token for ending. Now, you could say that, oh, this looks like XML shit. Like, this does look like XML, but it totally doesn't matter because this thing is going to be replaced with an ID, just a number, that inside the dictionary. By the way, not sure if I can go here and show it to you, but if we take a look at, let's say, a specific quantization and maybe the files, or maybe tokenizer, JSON hogging face. Basically, there is dear everybody, a JSON file. Oh, there is a too large to display. Too large to display. Basically, each model uses a specific tokenizer. Now I would need to run a gguf. Probably that would be an instruct model. Okay, so let's jump into Bielik. Sorry. So yeah, here we have the file. So now this is the gguf. So by the way, what is the model? The model is basically the package of all these parameters. So these are just binary bytes, right? This is the model. This is the whole meat of the model. And now I need to have a tokenizer. And yeah, shit. Now I hear in this exact one, I don't have the tokenizer, but still, there would be basically a big JSON. Maybe I will find it over here. Tokenizer JSON. Yeah. So this is how tokenizer looks like. So basically, this is token, special token 1, special token 2, special token 3, and so on. Now, each of these is a special token, but, and this is, by the way, this tokenizer is trained on some Polish text, never mind. But as you can hear over here, as you can see, there is something like przedmiotem in Polish, items, or whatever, or polskimi, Polish, whatever. So there was a word like this, happening frequently enough in order to get into the dictionary. And now, what is a special token? That's a special token. And that's another special token, or this. So does it matter that it's XML? Not at all. It's just an entry, and it would just have its own ID over here. But the problem is that you don't just introduce these special tokens, you need to retrain the model. And this is not only non-obvious, but it's also deadly expensive. Andri, so I think I will just go through all the questions until the end of the list, and we would end for tonight. Is there a way to share the context between different agents or share the same agent between users? For example, when several people are working on the same problem. So first of all, an agent is a program, right? That's important. Now, I hope you know at least the basics of cloud architecture. And in cloud architecture, you have a distinction between services, for instance, Java server, Python server, whatever, that are stateless, right? And there are stateful services, such as databases, caches, and so on and so forth. So, you should not mix the two, like one uses the other, like, sending the environment variables, what is, available where, etc., 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 these things. So a model, this guy over here, it's a stateless service, right? So it doesn't include, like, the vast majority of the times, it doesn't have any of the state. So by the way, if you, if the agent doesn't include all the history of your conversation, so all that have been asked and the answer and the question and the answer, etc., all the sequence of this, if the agent doesn't include the things, the model will not remember what has been said. That is very important here. And so the model is stateless, is very important. So the question is, can you share a service that is stateless? Of course you can. So I know you asked about agent and I'm answering about models because I want to cover the whole thing. So can you share model? Sure, because it's just a stateless service. Now, can you share an agent? It depends, what do you mean by that? So the agent does some work, but also it manages state. So the thing is, could you, I interpret it in a way that there would be one thread that is being, let's say, just as a Slack or Discord thread that multiple people are taking part in. So there would be multiple users and one model, for instance. So could you do it in Slack or in Discord? Absolutely, yes. But the difference between Slack, Discord, and other, chats and AI chat is that, for instance, if I write, let's say, please write a dry joke that is very long. Now, if I press enter over here, what? Yeah, so it's generating. And now I am blocked. Me as a user, I'm blocked here. Why? Because the model is responding to me. So only when now it's, the model has stopped responding. The agent has passed everything. So now I can continue. So imagine that you would have a conversation where multiple people speak here. So here is, let's say, it's me. Here is the model. And now there would be, again, me and the model. So what you would need to do is basically to solve a problem that we have drawn, just one moment, a problem that we have drawn over here. So here you have this blue dashed rectangle, so the agent loop. So the thing is, when you run a request to hold the agentic system, the model is going to decide what tools to use, what things to do, unless it finally gives you the answer. So there could be potentially multiple folks here, and the first one that writes a prompt would basically lock the conversation, freeze the conversation, unless the LLM answers, and then it would unlock it. This would be doable. Now, the question about user experience about that, I don't know. The question is, could guy number 2 cancel prompt from guy number 1? I don't know. Also, the agent would need to store the state of the session. So, for instance, whether the agent, whether the model is responding or not, etc. By the way, it's a very interesting question. Theoretically, it does make sense, but the problems that you would need to solve are purely software problems. By the way, agentic AI, like here with models, there is machine learning and data science. But with agentic software, it's purely software. So, you need to know databases, you need to know, cloud, you need to know, data structures, etc. So doing agentic stuff is basically software, right? This is data science, etc. Yeah, Andrei, I hope that's an answer to your question. Yes, that does make sense, but you would need to. So we could say that one possible solution is pessimistic locking, essentially. So the first participant of the conversation locks the conversation. Unless the model answers, then the conversation is unlocked. So there would be basically a race for any of the participants who first shot. If multiple people were to continue with the model, I'm not sure whether that would be token effective, to be honest. But that's a totally different area. Dmitro, is thinking process and what model returns included in context? Yes. Or at least it's provided. Sometimes it's just disappearing messages that model wrote in the middle of the response and then remove them. Yes, so it is there. So let me just open Olama list. And let's say Olama run, my favorite, absolutely favorite. Yeah, by the way, you can see here that I've got DeepSeek R1 8B, which means that this is quite significantly quantized model, right? Okay, so I've got Olama, and my favorite question is, what happened at Tiananmen Square in 1998, 1989? It never gets old. But still, as you can see, there is thinking, blah, 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 blah. So this is the gray thing. I'm not sure whether you can see it clearly, but this thinking part is grayed out and the answer is in white, right? So how do you think? What is this reasoning thing? I don't have a slide for it. Chat template, hugging, face, reasoning. But essentially, reasoning is yet another special token. Oh, by the way, here you've got not XML things, but square things. Anyway, it doesn't matter. It's just so reasoning, no, thinking. No, I don't. I can't see it. But anyway, if you have this sequence, then basically you would have a starting token for reasoning, and you would have a ending token for reasoning, and that's basically essentially the whole thing with reasoning. And now, Dmitry, you're asking, sometimes it's just disappearing messages. So it's just a matter of your user interface, whether it would be shown or not. And yeah, you're right. When you're doing something, tab functionality, whatever. Sometimes there is a thought for 4 seconds, and now I can see, oh yeah, this is the reasoning, blah, 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 blah. And now it basically disappears. So it's basically a matter of the UI. How do you show it? And now here comes the opening token for reasoning. Here comes the end token for reasoning. Here comes the opening token for the response itself. Here comes the end token for the answer. And that's basically it. Andrew, great answers. Thank you. I enjoyed this as well. Okay, everybody. So it was supposed to be 1 hour up to hour and a half. It's been 2 hours. So I hope you have found these things interesting and useful. So if I have something to leave you with, then that would be definitely, dear everybody, to think about, to make sure that when you're working with your, that when you're working with your agents, over here. Yeah, that make sure that you do refresh or reset or start new threads so that your context is not too big. That's one thing. And by the way, very last thing. If you remember my dry joke from the very beginning, that was, you are an expert, you never make mistakes. So how does that affect the model when you write you never make mistakes? So for you never make mistakes, there would be most probably to everybody, DeepSeek, GGUF, whatever, there would be some, let's say, related knowledge within the model about you never make mistakes. So semantically, like we haven't gone into, the internals of the models themselves, but still, there is some, let's say, semantic interpretation of what is the word expert, what is the word mistake, what is the interpretation of you never make mistakes. But if we say you never make mistakes, like, what does depend on how does that affect? First, what was the training data set? Was this phrase, you never make mistake, or you do make mistakes, was this phrase anyhow present in the data set? Now, if you put the phrase, you never make mistakes, into a training data set, and you expect the answer to be better, does it imply that without this sentence, the answer would be worse? Why would it be worse? If I'm asking to write me a React component, is it supposed to return me pure shit? And I only need to write you are a React expert to provide meaningful answer? Like, can you understand? Like, it doesn't make sense, essentially, right? This is madness, right? So, but it, as a rule of thumb, it all boils down to training data sets. And again, we have a problem with closed source vendors. Now, here on Hugging Face, we have this tab with models, and we have lots and lots of models, thousands of them. No, millions of them. But we also have data sets. Now, they are not wonderful. They're very far from wonderful, but they are open. And this is nice. And now imagine, let's say that we gather me and you all and other people, and let's say that we provide a model that would be super specialized in working on Docker or React or, I don't know, fast API in Python, whatever. And we provide an open source data set, for instance, on GitHub or whatever, wherever. But we would need to pay attention to what are the exact prompts, right? And what are the expected answers, so that then the training could iterate, calculate the gradients, etc. And the thing is, in such an open data set, we could find which, let's say, exact entries in the training data set is responsible for what. But if big vendors create their models with closed data sets, then what we can do? Nothing about it, right? So when we put this, when you put this, you never make mistakes, what even is this thing? And now, again, LinkedIn or, X shamans can tell you you should add it. Yeah, but how does that affect the thing? Well, it depends on what is the data set, and you don't know it unless it's open, right? So basically, I think it is a matter of time when we get there. Let's say we would have software-specific models, and they would have open data sets, because at some point in time, the random guy in Nebraska meme. Yeah. So random guy in Nebraska meme, which is probably Linus Torvalds, that the whole IT infrastructure is standing on, right? So at some point in time, there would be probably these open things, but we just need to wait for it. And then, if this is not present in the data set, then we could prove that this is pure nonsense, right? So you never make mistakes. How does that glue to the exact items in your data set? So, for instance, you could say that a component should be stateful, or stateless, or that it should be a higher order component, or I know render prop, or I know server side rendering, whatever. These things have meaning, right? But If you tell yourself you are an expert or you never make mistakes, what does it semantically mean in terms of coding in JavaScript, Python, Java, or whatever? Right? That's the thing, right? Okay. So, um, yeah, so dear everybody, one thing, think in terms of what semantically does it mean what you put into your prompts. And the other thing is think about making your context, let's say, smaller and cleaner so that your consumption gets smaller. So thank you very much, dear everybody. And yeah, let's hope to meet you again.